Greetings to you and welcome to Bengineer Construction Lecture Hub. Today I want to talk about how to design ROC beams. Alright, now when we talk about ROC beams, we are referring to reinforced concrete beams. Now, beams are known as flexural members, all right, and they transfer their load via bending. So what we have here is how to design ROC beams. We have first, you have to study the architectural drawing. Now the architectural drawing shows the various partitions within that building. So you must study the various partitions, then identify the various, that will take you to the next step, which is identify the various beam positions. You have to identify the various beams, the beams position. Now that will also, it has to do with the span it makes. There are some beams that in the building that is 4.5 meters, some 5 meters, some 3.6 meters, as the case may be. You have to identify their spans and also their supports. All right. Then the next thing you're going to do is to evaluate the beam size. You have to choose the depth of beam as well as the breadth of beam you intend to use for that particular beam design. All right, so you can choose maybe 450 by 450 depth, 225 millimeter breadth. Okay, you can decide to choose 300 millimeter depth, 225 millimeter breadth. So it depends on the section you want to make out of for the beam. Then the next thing you're going to do is to compute the load on the beam. Now, for you to compute the load on the beam, first and foremost, you must have designed the slab. Okay, you must have designed the slab. If the beam is hinged to a slab, you consider the slab load. If there are wall loads on that beam, you consider the load on that beam. If it's a roof load, you consider the roof load on the beam. Then you also consider the beam own weight, that is the self weight of the beam. So when you do that, you get the total of it. That becomes your dead load on that beam. So you analyze the beam. Now, analyzing the beam in this case, in the case of a simply supported beam, for example, you have a simply supported beam in this manner. Okay, a simply supported beam in this manner. You will know that the maximum bending moment, okay, the maximum bending moment here will be WL square over 8, sorry, becomes W over 8. All right, so this becomes your maximum bending moment. Okay, this becomes your maximum bending moment. So from analysis now, you can obtain the maximum bending moment. So once you have done that, the next thing you're going to do is to calculate the design ultimate load. Now the design ultimate load is 1.4 GK. This GK is the dead load plus 1.6 K QK, which is the life load. Now the life load for residential building is 1.5 kilonewton per meter square. All right, so you substitute that there, then the total you get from here is what you will impute here, and you work this out. Whatever it gives you becomes your F. Now this F is the same thing as your W. Okay, is the same as your W. Then you consider the span of the beam, okay, from one support to the other. All right, that will become your L. Then square divided by 8. Whatever it gives you, that becomes the moment. Then you come to compute for the moment, okay, which is what we have done for 7. Compute for the moment, which is this. Now calculate the K value. K value is equal to M divided by FCU BD square. All right, so this moment is what you get from number 7. You substitute it here. Then FCU is the characteristic strength of concrete, which you must have considered during the design. All right, then BD square. this is the breadth, this is effective depth. But before you get to this point, you have to compute for the effective depth. Okay, the effective depth D. Okay, you have to compute for the effective depth D, which is equal to H, okay, minus CC, okay, minus the diameter of stirrup, okay, minus diameter of bar, of rebar, okay, divided by 2. So whatever it gives you here becomes your D. All right, this is the overall depth of your beam. The concrete cover, diameter of stirrup, diameter of rebar divided by 2. So whatever it gives you, that is what you substitute here as your D. Your B is 225. That is if it's a 225 width of beam you're considering. So when you